Is it a polynomial? So here's some examples of polynomials. Polynomial is a bunch of terms that are added together that are numbers and variables to a positive whole number exponent. Here's two examples of polynomials. Here's some examples of things that are not polynomials. This one's not a polynomial because of the x in the bottom. These other things are fine, but you can't have an x in the denominator. And this second one is broken because of the y to the -3. So there's nothing wrong with having an x and a y together, but you just can't have it to a negative number. And then this one's broken because of the square root of x. So let's try some of these. So number 1, 4x cubed plus 2x minus 3. Is it a polynomial? Well, there are no negative exponents. There's nothing in a denominator. There's no square roots. So I'm going to say yes, this is a polynomial. And yes, it is. Number 2, 3x squared plus 5x minus 12. Is it a polynomial? Once again, I'm going to say yes. There's terms added together. There's no negative exponents or stuff in a denominator or a square root. Now for this one, 2 over x, this is no. This over x is what breaks it. So it's not a polynomial. Number 4, 3x squared minus x plus 4y squared plus x minus 2. So this one, even though there's an xy here, that's totally fine. Nothing wrong with that. This just has a bunch of terms being added and subtracted. Totally fine. So yes, this is a polynomial. Number 5. Is it a polynomial? So this one has the square roots in it. Square root of y, square root of x. You can't have a square root of a variable in a polynomial. So this is no, not a polynomial. Number 6. 2x plus 3. Is it a polynomial? Yes. There's nothing wrong with it. Two terms added up. It's totally fine. Number 7, xy to the -3 plus 3x. This is not a polynomial because of this -3. So because of the -3, it is not a polynomial. The answer is no. Number 8, 3 over x plus 2. Oh, 3 over x plus 2. We can't have it over x. The answer is no. This one's not a polynomial. Number 9. X over 3 plus 2. So even though this has a denominator, it's a number that's in the denominator. So that is totally okay. We could think of this as 1/3 x plus 2. In that case, it's just a number times a variable plus a number. And in that case, it is a polynomial. It's two terms, and the variable is not in the denominator. So this is totally okay, which is different than the one right above it with number 8. That was a no because it had a variable in the denominator. But a number in the denominator is totally okay. Number 10. Is it a polynomial? Yeah, it's fine. It's 3 terms added up. No problem. Number 11. Is it a polynomial? Once again, there is a denominator, but since these are just numbers in the denominator, they're totally fine. So we could think of this as 1/3 x squared plus 2/5. In which case, just a number, a variable to a positive exponent plus a number. So the answer is yes, this is a polynomial. Number 12. Same thing, looks fine to me. Yes, it's a polynomial. Number 13. So I see a square root. So there's a little flag, but this square root is only of a number. So it's totally fine. Square root of 3 is just a number. And then we have our x squared plus 1. So we have a number, variable, positive exponent plus 1. Totally fine. It is a polynomial. Number 14. Oh, so the difference between 13 and 14, now the square root on 14 is with a variable. That is not a polynomial. You cannot have a square root for a variable. So the answer is no. Number 15. Pi. Pi plus 5x. Well, pi is just a number. So this is a number plus a number times a variable. That is fair game. It is a polynomial. And then -3x to the 4th. Well, this negative in front is totally fine. -3 is a number, 7 is a number, x to the positive 4. This is all totally fine. So yes, it is a polynomial. If you want to try going through these again, I have this page on andymath.com. I have a link down below in the description. Please like this video and subscribe to my channel, and I'll talk to you guys soon. Bye. Andy Math.